Hello, math champions. This is Mrs. Al Shaima Salah. Today we will learn Unit 2, Concept 1, Lesson 4, Comparing and Ordering Rational Number. Let's start. To compare and order rational number, we have to see the number line. This is the number line. Okay, going to the right is the ascending order, coming from the smallest to the greatest. Descending order is the opposite. Coming from the right to the left is the descending order. It means coming from greatest to smallest. Let's have an example. For example, 1/3 and 4/3, which is greater. Of course, 4/3, 4/3 is to the right of the 1/3, so it is greater. Yes, excellent. Another example, 2/3 and minus 2/3. Take care of the sign, minus 2, negative 2/3 and negative 5/3 is what, greater or smaller? Tell me, math champions. Excellent. 2/3 is minus 2/3 is greater than minus 5/3. Okay, let's now comparing two rational numbers. If you have two numbers that have different signs, then the positive number is greater than the negative number. An example 0.05 is greater than minus 15 over 2. Okay, because it is positive, it is greater. Okay, the next one, if one of the two numbers is greater than a certain number x and the other number is less than the certain first number x, then the first number is greater than the second number. For example, okay, the fraction 65 over 63 is greater than 75 over 57 over 59. Why? Because 65 over 63 is greater than 1 and 57 over 59 is less than 1. So 65 over 63 is greater than 57 than 59. Okay. If two numbers are in the form of A over B and have the same positive denominators, then the number having the greater numerator will be the greater. An example, if we have 7 over 13 and 5 over 13, because they have equal or the same denominator, 7 over 13 is greater than 5 over 13 because 7 is greater than 5. Another example, if the two numbers are in the same form A over B and have the same positive numerators, then number having the greater denominator will be the smaller. As when the denominator gets greater, the fraction gets smaller. Remember that if I have a cake and I divide it on 4 quarters for 4 person, and another similar cake and I divide it into 8 eighths for other 8 person, the person having the quarter having a bigger cake than the person having the 8. Okay, just remember the cake and you will understand. An example, 2 over 5 is greater than 2 over 9. You can see that when the denominator is smaller, the fraction is greater. And if the two numbers are in the form of A and B and different numerators and denominators, first thing to do is to convert. See this one, convert the two numbers in order to have common denominator. Taking care of denominator should be positive and then compare their numerators. Make sure that denominator is positive. What we will do to convert, we will get what? Math champions, excellent. We will get the LCM. Remember that you will use your knowledge to get the LCM and get the like denominator. And example. Yes. 2 over 3 and 8 over 15. Which is greater? 2 over 3 is greater. Why? Because when we convert 2 over 3, it was 10 over 15, and 10 over 15 is greater than 8 over 15. And now we will have an example. Convert the two numbers in each of the following using a suitable sign. Sorry, it's not convert, it's compare. Compare the two numbers in each of the following using the suitable sign. Less than, greater than, or equal. Let's start. 7 over 12 and 5 over 12. Which is greater? We have the same denominator. What we will do, math champions? You should answer. Excellent. 5 over 12 is smaller than 7 over 12 because same denominator and 5 is less than 7. Okay, another example. Quarter and minus 5 over 6. Which is greater? Quick math champions. Excellent. Quarter is greater than 5 over 6 because quarter is a positive sign and minus 5 over 6 is a negative sign. Okay, next. 11 over 12 and 11 over 15, which is greater? Excellent question. First of all, what we will do, we will look at the denominator. They are different. The numerator is the same. So the bigger in denominator is the smaller in fraction. So 11 over 12 is greater than 11 over 15. Okay. Another example, 6 over 12 and 2 over 3. We have different numerators and denominators. Both of them are positive sign. Who can tell me? Excellent, excellent. We will convert 2 over 3 and it will equal 8 over 12, and we have 6 over 12. Of course, 6 over 12 is smaller than 8 over 12. So 6 over 12 is smaller than 2 over 3. Okay, next. 3.2 and 11 over 12. A decimal and a fraction. What we will do? Think, math champions. Excellent. We convert 3.2, it will be 3 and 2 over 10. Convert 11 over 2, it will be 5 and half. So 5 is greater than 3. So 3.2 is smaller than 11 over 2. Okay, next, 2/3 and 4/5. Both of them are positive. Tell me, math champions, which is greater? Excellent. We convert 2 over 3 and 10 over 15. It will be 10 over 15, and convert 4 over 5, it will be 12 over 15. So 10 over 15 is smaller than 12 over 15. So 2 over 3 is smaller than 4/5. And next, 3.7 and 3.15, which is greater? Tell me, math champions. Excellent. 3.7 is greater than 3.15 because zero point 0.7 is greater than 0.15. Another example, -4 and -4.1. Tell me, math champions, which is greater? I'm waiting. Excellent. -4 is greater than -4.1 because on the number line in the -4 is before 4.1. Okay, and move. This is a new idea, new concept. What is the density of the rational number? Density of the rational number. Between every two different rational numbers, there are an infinite number of rational numbers. This is the property of density. Okay, this is the property of density that tell us that between every two different rational numbers, there are an infinite number of rational numbers. Let's see how. We'll draw a number line. We will put 1/3 and 2/3. As you can see here, we cannot find any rational number between them. But if we look deeply, we will find that if we multiply the 1/3 by 2, it will be 2 over 6. And the 2/3 by 2, it will be a 4 by 6. So we will have a new rational number between them, which is 3 over 6. Also, looking a little bit more deeper, if we multiply the 1/3 by 3, we will have a 3 over 9. And if we multiply 2/3 by 3, it will equal 6 by 9. So we have two rational numbers, which is 4 by 9 and 5 by 9. So the key word here, or the tip here, is fragment. We fragment the number line into a little pieces, smaller and smaller, so we get more and more rational numbers. It is fractions, that's why we can fragment it and have an infinite number of rational numbers between each two numbers. Okay, this is will to a remark we should understand. Okay, first remark is integer numbers does not have property of density. So there is no integer between any two consecutive integers. Take care, I cannot find that property in the integer set. Okay, and for any integer, we can very easy, very clear determine the integer which lies just after and just before it. Okay, but for rational number, because of the property of density, we cannot determine the rational number which is just lies before or after it. Okay, take care and think deeply in these remarks. Okay, Because of what we cannot find the rational number? Because it is infinite. It is fragmented. You can fragment it easily and determine an infinite number of rational numbers between each two numbers. Okay, let's have an example. Find a rational number lying between half and 5 over 7. What we will do? First, convert denominators into like denominators. Okay, then what? Half will equal 7 over 14. And 5 over 7 will equal 10 over 14. So we can easily say or decide that the rational number between 7 over 14 and 10 over 14 is 8 over 14 and 9 over 14 lies between them. And any of them is a correct answer. If I took 8 over 14 and say it is the number, it is correct. 9 over 14, it is correct. And any other number you will find, it will be correct. Between them, you have to fragment, okay? Example, minus 2.1 and minus 2. What we will do? Yes, first fragment the number line between the two lines, the two numbers, and I mean the two numbers. What we will do, 2 minus 2.1, it will be minus 2.10, okay? And minus 2, it will be minus 2, it will be minus 2.0, and you can decide the rational number between minus 2 and 0.0 and minus 2.10. Okay, between them there are minus 2.01, negative 2.02, negative 2.03 until you reach negative 2.09 are lying between them. خلاص, any of them is a correct answer. Okay, thank you much, champions. Wish to see you next time. If you have any questions, any problem, just put it in the comment box and I will come back to you. Thank you very much. Goodbye.